everybody for joining me. I know it's late into your evening. I appreciate giving the opportunity to let me talk a little bit about Pulumi. I will start off by saying that I am a sales engineer at Pulumi now, but I'm not here to sell you the products. I'm here to talk about my background, a little bit about what Pulumi does, and I'm not going to talk about anything other than the open source project at this point. So a quick introduction about me. I am Lee Briggs. I'm based in Seattle, Washington. As you can probably tell from the way I'm speaking, I do originally hail from the UK in Yorkshire. It's been a while since I've lived there, so my accent isn't quite what it used to be. But I've lived in Seattle now for 4 years. And my background is as an infrastructure engineer. So I started out as a system administrator, being that person who told you weren't allowed to deploy to production, and have kind of gone through different ways the infrastructure industry has changed, and I'm now working at Pulumi as a self-titled community engineer, because I don't like putting sales engineer on my LinkedIn. So I have a Twitter account. If you have a Twitter account, I have a GitHub where there's lots and lots of Pulumi examples amongst other things, and then I occasionally write on a blog when I don't want to do a 600 thread Twitter thread, which seems to be the new rage at the moment. So when I started in the industry, this is what infrastructure looked like. I literally would go to data centers and rack and stack servers, and I worked for a large organization for nearly 10 years, in which sales engineer is not my favorite way of referring to it. But anyway, I used to rack and stack servers in data centers and cable them, and this was my general cabling strategy: is just throw a cable in and then check that it works. But as I'm sure you're all aware, infrastructure has changed really dramatically, certainly in the last 5 years, but over the last 10 years, the way that we provision infrastructure has really been very, very different. And this is just a screenshot of the Azure portal. You may be more familiar with Google Cloud or DigitalOcean or AWS or any of the other cloud providers. But ultimately, what it really means is that the infrastructure that we are used to dealing with is on demand, it's faster, it can get into your hands way quicker. I'm not here to talk to you about the benefits of adopting the cloud. You may work in an organization that doesn't use any cloud services, but ultimately this is the way the industry is going. It's we may see something over the next 10 years in which people move back from the cloud into data centers, but I would be very, very skeptical about that. With this change in infrastructure, the way you provision infrastructure has also dramatically changed as well. Once upon a time, you might open an issue with your operations team and ask for a new virtual machine, and eventually they would hand you an IP address and an SSH key. Obviously, with the advent of cloud services, we need to change the way that we actually think about the way we provision infrastructure. And what ended up happening is that we as an industry generally tended to converge around this idea of declarative infrastructure. So you're going to say, I want this infrastructure from my cloud provider, and it's going to be driven towards a desired state. This really generally started back with the ideas of Puppet and Chef and CF Engine, and to a later extent, Ansible. That declarative infrastructure model at the operating system has really kind of been pushed into the API-driven layer with tools that you may be familiar with, like Terraform or CloudFormation, and of course, Pulumi. So this declarative infrastructure model of saying, this is how I want the world to look, really started to come along when we started to adopt cloud infrastructure. And as a result of that, configuration languages have really taken off. You've probably, if you've worked in any cloud environment before, you've probably declared some infrastructure using YAML if you've used CloudFormation on the left here, or you've probably used some JSON, or at least something that at least compiles down to JSON. This is an ARM template inside Azure, and you can author those ARM templates in JSON or YAML, and a very similar thing with CloudFormation. Using these configuration languages really helps with that desired state driven declarative infrastructure, because you can basically map out the data that you actually want to define, and then submit it to an engine, and the engine will drive towards that data. However, I am on record stating that I have a loathing of YAML. This is one of my favorite tweets about why YAML is not really a fit for purpose infrastructure declaration tool. I could do a whole hour-long talk about it, but I'm not going to get into the, my philosophy around YAML. You've probably used YAML at some point in your life, and you've probably used it for configuration. So obviously it would make sense you would use it for infrastructure, but as an authoring tool, as a thing that allows you to actually be expressive, if you want to do anything above a static map of keys and values, you have to start implementing a templating engine. And so you may have heard of, or you may have used Helm, which uses Go templates, or something that uses Python templates to actually template the YAML. Ultimately, when you want to get that expressivity in YAML, you are going to have to reach for another tool in order to make it fit for purpose. And then, of course, there's the JSON problem, like hand authoring JSON. Again, we're talking about the authoring model here. Hand authoring JSON is an extremely difficult and painful thing to do outside of a few lines. I certainly wouldn't want to define complex infrastructure using JSON. You can't add comments, etc., etc. It's a really great format for configuration. It's not necessarily a great format for authoring. So as a result of these two problems, I think I'm not obviously the person to necessarily define whether YAML or JSON is the worst configuration language. This is just my personal perspective, but I think it's indicative that we have seen so many solutions be created in order to kind of author these configuration languages. This is just the ones that I'm aware of off the top of my head. HCL, if you use Terraform, essentially is a mechanism for authoring JSON. It's a little bit more expressive. It has some conditional logic in there, but not a lot. It has the count mechanism, a bunch of other things. But HCL's ultimate purpose, if you've ever used Terraform, you can actually author an entire Terraform manifest using JSON if you really want to. But HCL is essentially a solution defined with the problems of JSON defined. And then there's JSONet, which was pretty popular in the Kubernetes community for a hot minute, has been superseded by the Q language. Bicep, if you're in the Azure ecosystem, is the new thing that they're pushing. And then if you are really one of those niche people, you'll notice it only has 19 stars on GitHub there. But DAL is a really interesting language that allows you to, again, define configuration and will transpile down to JSON. All of these have their own problems, and ultimately, at least they have their own problems from my perspective. Ultimately, the problem lies with the idea that you are essentially creating a configuration document that you will then use to define your infrastructure. So infrastructure as code is a ubiquitous term, but I find it a little bit of a misnomer because the idea of code really talks about configuration languages. So I like to use the term infrastructure software when I'm talking about Pulumi. And what does software look like? Well, when you're writing software, as you're all Go programmers, I'm sure, writing software has a bunch of different considerations. You need to think about the different abstractions that you want to use. Like, how do you make reusable abstractions in Go? Obviously, it's not necessarily fully object orientated, but it has different interfaces and methods and stuff that you can use. You want to be able to write tests for it, which is really, really hard in all of these different languages. Writing tests for HCL usually will expect you to reach for an actual fully featured programming language. If you've ever used something like TerraTest, you have to write Go rather than HCL for your tests. You probably want to have some indication of your control flow, whether that's if statements, loops, conditionals, all those different things. Really important when you're writing software. And then the most important thing that I really like to talk about is expressivity. If you've written Go before, if you've ever authored anything in the Go programming language, you probably feel that you can be extremely expressive in the way that you want to write things. You can reach for interfaces when you need them. You can reach for methods when you need them. Channels, asynchronous communication. None of these things are possible when you're writing infrastructure and configuration languages. So here is an example of writing Pulumi code, not in Go. Here's an example of authoring infrastructure using Pulumi's TypeScript SDK. And this is the last time I think you're going to see the TypeScript SDK, but I want you to just take a moment and look at what this is actually showing you. It's showing you that you can have an abstraction. In this case, it's a Pulumi component resource, which is just an extension of a class in TypeScript. You can see that I can also define the input interface that I want for this component resource. If you were writing this in a configuration language, you would have to have some kind of wrapper around it. You wouldn't be able to define a type on there at all. So this is an idea of using programming languages to actually define your infrastructure. And this is what Pulumi brings to us. So to pause there, Pulumi is an infrastructure as code platform that allows you to use the application programming languages that you're already using. So the things that you're using to build your backend in Go, or the things you're using to build your front end in TypeScript or Python or anything else that you're using in your application programming lifecycle, Pulumi allows you to use these programming languages to define your infrastructure instead of using those configuration languages. We currently support the Node.js ecosystem, so JavaScript and TypeScript. We support the .NET ecosystem, C#, F#, and VB.NET, if that is your particular poison. We support Python, and of course, we support the Go programming language. We also support all of the clouds that you have heard, that you have probably, I've just noticed that I've cut off this Kubernetes logo, but we support most of the cloud providers that you have heard of, and probably some that you haven't. So Amazon Web Services, Azure, Google Cloud, DigitalOcean, Fastly, etc., etc. If you are familiar with CloudFormation or maybe AWS CDK, that is very much in the remit of only a single cloud provider. And so you are kind of baked into the AWS ecosystem when you're using AWS CDK. Pulumi's unique value proposition is that we support providers for a wide range of different providers. And not only that, but we also allow you to use our native providers, for which we have support for Kubernetes, Azure, Google Cloud, and AWS, which means that we generate all of the resources for those cloud providers directly from their APIs. And to give you an example, Kubernetes launched the 1.23 release yesterday, and we had support for it before their release mechanism had actually finished. So the Kubernetes release mechanism takes 5 or 6 hours at this point. And because they generated the schemas for version 1.23, we were able to release a version of our provider that had all of the new resources supported in it inside that Kubernetes provider. Similar thing with AWS. I was at AWS reInvent last week. They announced a whole new bunch of resources like VPC IP Manager. We already have support for those because we generate those resources directly from the upstream providers. As Go programmers, you may find it interesting that we write all of our providers in the Go programming language. So Pulumi's command line interface and all the providers are actually built in Go. But obviously we have these downstream SDKs that you can actually use to author your infrastructure. So I'm going to pause there. Any questions? I'm going to take no questions as a good sign. If you want me to cover anything else up to this point, like post it in the chat if you don't want to unmute yourself, but happy to take any questions at this point. Awesome. I shall continue. So let's talk a little bit about a Go ecosystem with regards to Pulumi. Why would you use Go instead of any of these programming languages? Obviously, we have a range of support. I'm talking to a Go meetup here, so you're all familiar with the benefits of Go. This is my perspective on why you would choose Go as a language when it comes to authoring infrastructure. The first is it's fast. I can write the same program in TypeScript and Go is an order of magnitude quicker in Pulumi simply because of the nature of its fast compile times. The strong static typing is really, really helpful when you're actually defining infrastructure. I'm going to do a demo in a few minutes. Hopefully that will give you an idea of what that experience looks like. Cross-platform binaries, I'm going to come back to this at some point, but those cross-platform binaries are super, super important. And then a built-in testing mechanism. So not having to add an additional library or anything along those lines in order to actually test the infrastructure, I think is super important. I'm just going to read the comments here. Yes, to answer the question. So the question is, for those who are watching the recording, does that mean if say GCP releases a new service, we can immediately get all the config options because you base everything on the REST API? Yes, that's exactly what it means. So if it's supported in the Google Cloud API, we immediately get support for that. And if you've used any other infrastructure as code tool like Terraform, Crossplane, any of the other infrastructure as code tools, they usually rely on somebody submitting an upstream pull request that adds all the parameters. We generate those resources directly from the upstream API. So like I said, as an example, AWS supported added support for VPC IP address management, VPC IPAM. We already have support for it because it just gets added to the AWS API, and we immediately generate those properties, and it becomes available in the SDK. So it happens. Obviously we have to run the generation that we run every single day. We run it every 24 hours. Usually for big release announcements, we'll run it shortly after the release announcement, and it's usually been published immediately. So if you've ever used another infrastructure as code tool and it's missing features from the upstream API, I guarantee you that we almost certainly have support for it. Hopefully that answers the question. Cool. So back to the reasons you might use Go. We talked about built-in testing last. So let's take a look at what this actually means in reality. Another thing that's really important to know is that you get this, you get the productivity levels that you get from using a language that has a language server supported in your IDE means that your productivity goes up dramatically. If you've ever used any YAML-based configuration language to define infrastructure, you're probably used to the idea of cross-referencing all the supported arguments and all the things that you need in order to actually define the infrastructure. Here's an example that I put together yesterday. I'm going to show you this in real time in a few moments of what it looks like to actually author things in Go, but I can immediately get that kind of at the edge of my fingertips feeling when I'm writing infrastructure code, because I am able to actually use the language server to investigate all the different options that I have. And I'll show you an example of what that looks like, but this is a really powerful mechanism. One of the things that I hear from customers almost every day is how much more productive they are in Pulumi, because they get to use the languages that they already feel comfortable with, but also because of this kind of quick feedback loop that they get from using these infrastructure, these programming languages. And that's not just as a result of the language server, it's also as a result of the strong type system that you get in Go. So, if you've used another, like let's say CloudFormation, you probably at some point passed the wrong parameter to a YAML input, and you have to wait for CloudFormation to tell you that you've screwed it up. Whereas with Pulumi and the Go programming language, you automatically get that feedback directly from your IDE. The other great thing about using Go for your infrastructure definitions is that when you create abstractions, it's really easy to just go and reach for them using the Go modules package management system. You're obviously free to use whichever Go module package management system you like, whether it's Glide or DEP or whatever, but you are able to pull down these reusable abstractions and our providers using a simple Go get. And I think this is really powerful. If you have ever tried to get somebody who is not necessarily a infrastructure focused person to use another tool, like whether it's Terraform or CloudFormation, one of the first things that they immediately will tell you is like, I have to learn a whole new ecosystem. I have to learn a whole new set of commands just in order to be productive. If you're already writing backend systems in Go, you've almost certainly used GoGet to pull down some dependencies. So now you get the ability to do that when you're defining your infrastructure too, which is really, really helpful and really, really important to get that kind of feedback loop and that productivity going. And then the final thing that I'll talk a little bit about here is the idea of testing. with most infrastructure as code tools, they will only allow you to define integration tests. So you actually have to, first of all, you'll have to usually write it in Go. Like, for example, Terraform expects you to write tests in Go, and then it will actually go and create the resources and then look at the resources and verify them to see that they've actually been created with the correct parameters. Pulumi, because we're using the Go programming language, you can just write a simple unit test that will actually examine the actual created schema for the actual infrastructure components, and you can examine them like you can see here. I'm just looking through all the different ingresses and checking if it's open to the internet, and if it is true, and I can actually assert on that particular result. And I don't have to go and create any infrastructure in order to do this. So what that means is, of course, that you can refactor really easily. You can move things around and put them into different abstractions really easily. I use these unit tests all the time. We, of course, have an integration testing framework that will actually go and spin up a bunch of resources and validate they look the way you want them to. But these unit tests and the feedback loop is really, really powerful. And that test-driven development when your infrastructure is so important. It's such a vital part of your production infrastructure. Being able to unit test it really helps when it comes to refactoring and making complicated changes. I previously worked in a very, very large Pulumi stack, and adding these infrastructure tests meant that people felt way more confident in making changes to infrastructure, because you could just update the test, make sure they pass, and then you would feel good applying the actual Pulumi code. One other thing that I like to really talk about real quick is the idea of control flow. And you can see here, if you've used any other infrastructure as code tool, a simple if statement is generally not available to you. With Pulumi, because you're using the Go programming language, if statements are a second nature. You can do loops inside your Pulumi code, which I'll show you in a few minutes. You can do conditionals. Here, what I'm doing is I'm setting a configuration document, and I'm saying, if we haven't set the Kubernetes version as a configuration variable, fall back to a default version of 1.18.14. That expressivity really does change things when you're actually defining your infrastructure. Here's an example of an abstraction. So earlier on, I showed you an example of an abstraction in TypeScript. This is an example of an abstraction in Pulumi's Go programming language. You can see here, it's just a method on a Pulumi context. We are able to define a struct with the different inputs that we can set for our particular abstraction. And then you can also specify arguments to that in the actual struct itself. This can be turned into a Go module that you can then distribute to lots of different people. And you're essentially just using the same mechanisms that you would use when you're defining any other Go code. So I'm going to show you a little bit of a demo now that's starting really simple, and then we'll kind of get a little bit more complicated as time goes on. We're not going to talk about abstractions just yet. All I'm going to just do is show you the experience of authoring something in a Pulumi program. So in true Blue Peter style, I already defined some of the stuff here. So you'll see here's one I made earlier in terms of like grabbing the correct AMI. Here's a security group for an EC2 instance, and then I've defined some user data. So you can probably tell, if you're familiar with AWS, what I'm going to do is I'm going to create an EC2 instance, just a very, very simple piece of infrastructure. And what I will do is I'll define a couple of variables. Equals EC2. And you can see I've imported the EC2 package from our Pulumi SDK here. And then I can use IntelliSense to actually, the actual language server, to actually start to get feedback from what I'm actually going to be authoring. So I'm going to create this new instance. And you can see I'm already getting feedback directly from my IDE about missing arguments here. Again, if you've written Go before, I'm sure you all have. This is pretty familiar. But if you're used to writing infrastructure code, this is probably pretty new to you, because server, web server, www. If you're used to writing infrastructure code in something like Terraform or in a YAML YAML-driven infrastructure application. This is probably pretty new to you because that feedback loop usually relies on you actually doing an application and actually getting the feedback directly from the API. Whereas here, because I'm using this strongly typed language, I actually get that feedback immediately without actually having to worry about how the authoring experience looks like. So if I'm defining a new EC2 instance, you can see my IntelliSense is saying that I need some arguments, and I already know the type of that argument. So it'll be EC2.instance args. And then I can specify some parameters. So I need to specify an instance type, and let's give it a t2.micro. And I'm going to pause there because you're probably the first question I always get when I do this demo is, why do you have specific types for strings? Well, there's an answer for that, and it's not the answer I love to give, but because you're all Go programmers, you'll understand it. Go's lack of generics means that we have to define a certain set of types for anything that will come back from the API as an eventually resolved property. So for example, when I create this EC2 instance, it's going to have a parameter on the API that, even though I'm defining it, it's also going to have a return parameter that is eventually going to be resolved once that infrastructure is created. As a result, with any Pulumi dot, so a Pulumi dot output, any of these types is essentially saying that it will eventually be resolved asynchronously. Once generics lands in the next version of Go, 1.17, we intend to change this so that these types are no longer needed. But if you've ever used the AWS SDK, you're probably used to doing AWS.string. It's a very similar reason, basically. Are there any questions about that? Just open up the chat box. No questions. Okay, I shall continue. So I'm going to keep rounding this out. So we're going to add a VPC security group ID dot string array. Stupid question. Stupid question because I'm used to Terraform, and cloud providers have rapidly evolving APIs. How do we do versioning? I.e. in Terraform, we can limit provider versions. What will be a similar analogy for Pulumi? That's a great question, and I probably should have covered it. You just use Go modules. I mean, you're using Go modules to pull in all the other stuff. So you can see here, I've constrained my version of the AWS SDK to version 4.31.0. I can use all of the flexibility that comes with the Go modules SDK. So I can constrain this. I can do a replace if I need to, if I want to use a local version. Like, you essentially just use the package manager of your choice in whatever language that you're actually using. So if you're using TypeScript, it would be NPM. If it's Python, it would be PyP or pip, and in .NET it would be NuGet. But this is how you constrain the versions. You don't have to learn a kind of custom syntax. There's no custom package management with it at all. It's literally just Go modules, and this will actually constrain things in the right way. Does that answer your question? I'll give you a second to type. Excellent, thank you. Okay, so we're going to define some security group IDs. We're going to define and this is going to be a string array. And then I'm going to do something interesting. So you can see up here, I've defined a new security group, and I've given that security group to the variable group, right? So what I can do is I could hard code this. I could do something like this, right? However, Pulumi needs to know how these two resources depend on each other. It needs to be aware of how the security group that we're creating is going to relate to this instance. So what I can also do is I can pass the output from this particular variable as an input to this EC2 new instance. And when you do that, Pulumi is able to resolve the dependencies between these two resources, and it starts to know to do things in the right order. So because I'm passing an output from this particular group here, and you can see these are all the different outputs that I have. I can see the ARN of the security group. I can see the owner ID, the VPC ID, all of these different outputs that are available. And again, they're all at the end of my at the end of my fingers with the IntelliSense. But what that means is that I can create dependencies between them. And I want to show you real quick what happens if I give And that's not a good answer. Let's see if we can find, that's a string output. I think the ID is a string output. This is a bad example. So what I was trying to do is say, if I give the wrong value here, if I say that I want to specify a integer rather than a string, again, I'm getting that feedback loop directly from my ID. So I'm getting a quicker authoring model without having to worry about anything going wrong later on when I go and do the application. If I had populated this security group ID incorrectly, let's do this int array. Like so, it's going to tell me immediately that I'm passing the wrong type. This is one of the huge advantages of using the Go programming language for authoring infrastructure. If you use something like Python, Python's type system has been bolted on as a secondary consideration. And so you don't get the same flexibility. We have a lot of Python users because we have a lot of people from the data science community defining infrastructure. But Python's type system with MyPy is a second-class citizen, where with Go, it's a first-class citizen. I'm sure you're all aware. I'm going to do something similar with the AMI ID. So you can see up here, I've defined an AMI by looking up an AMI. And I hope you're getting the experience here. Like, it's pretty much telling me what I should pass here, right? Like, I've already defined an AMI variable, which I've assigned up here, and I'm getting the ID back immediately. And then I'm going to get to pass my user data like so, which I've defined here. And I think that's everything that I need at this point to make this Pulumi program work. So let's format that with Go format. And then I just need to, does not equal nil, because we're using Go format.errorf, error creating EC2 instance. And then I need to use my variable. So what I'm going to do here is ctx.export IP address server.public IP, like so, just to make sure we're using this variable. So this is going to create an EC2 instance. It's going to create a security group. It's going to look up an AMI. And of course, I have and now I need to actually specify the error. So this has created a, I'm just going to do panic because I'm a good Go programmer. Error creating EC2 instance. So this is going to create an EC2 instance, and let's have a look what that looks like. Let me make this a little bit bigger. I need to be in this window. So I'm going to drive this by using the Pulumi up command line interface. And what's going to happen is you're going to see that it's going to create a security group and an instance. I can examine the details, and you can see my T2 micro is there. My user data is there. You'll notice it's resolved the AMI for me and looked it up, so I don't have to actually define it as a hard-coded thing. And then anything that is not actually defined yet, so you'll see that our VPC security group ID there is going to be pulled from this security group. So it's currently defined as an output string, which means that eventually it will be resolved. So let's go ahead and create that. And you'll notice how fast that started creating, because the Go programming language is so fast. Like when TypeScript, it actually has to compile it to JavaScript first, so it takes a little bit longer. And Pulumi is taking care of like resolving those API updates. So it's basically saying, wait for Amazon to create an EC2 instance. Wait for Amazon to create an EC2 instance. So it's continuously polling that API to make sure that the EC2 instance has been created. Amazon does not value your time, and so it will take a little while to do that. If you've ever created an EKS cluster in AWS, you'll probably have sat waiting for infrastructure code many, many times. So it's going to go ahead and create this EC2 instance. And while we're waiting for that, are there any questions? No questions. That's a good sign or a bad sign. We'll decide which way later. So now it's created our EC2 instance. You'll notice it's also exported our IP address because I did an export down here. So it's actually providing me the IP address it's created. The thing that I want to show you now, though, right, is that if you use the AWS SDK to create any infrastructure, like the AWS Go SDK to create infrastructure, you're probably thinking to yourself, okay, this is imperative code. So why am I not having to do something like if server equals true, do nothing, right? Why am I not having to check that this server has been created and this group has been created? Well, the answer to that is that while Pulumi uses imperative code with the Go programming language, it defines a declarative end state. And I can show you exactly what that means by rerunning my Pulumi up. We've already created a security group. We've already created an EC2 instance. And you'll notice Pulumi is going to say those resources have not changed. So I don't need to do anything. It's still driving towards that desired end state. It's still defining a declarative end state, but the authoring model is very, very different. So how about we make a change to this particular infrastructure? Let's add some tags. And I think it's a string map. And then I'm going to define a name and then pulumi.string web server www, like so. I don't need a comma at the end, and then I need to format. Okay, so we made a change to our EC2 instance now, and previously we hadn't made any changes, so let's have a look what happens when we run a Pulumi up. You'll notice that it's going to update that actual EC2 instance because something has changed. And hopefully this is showing you that Pulumi drives towards a desired end state. Something that commonly gets asked of us is like, Pulumi's an imperative thing, right? And the answer is absolutely not. Pulumi does not use imperative code. You don't have to do conditionals. You don't have to check if any of this exists or anything like that. How does this work when it comes to conditionals and loops? Well, let's get a little bit fancy here and let's create these EC2 instances in a loop. And I want to do, let's create 5. And let's do I++, create a loop. And I'm going to have to do a little bit of rejigging here. What's wrong with this? I promised myself I was going to do some live coding, and now I'm completely regretting it. We can't assign that to a variable, so we don't want to use a variable there, and we don't want to do this, and we need to %d I format.sprintf. Okay, that looks good. So what we're doing here is we're going to loop through a standard for loop 5 times and create a new EC2 instance each one of those times. And the reason that I'm showing you this is because what I want to get across is that even though I am going to use an imperative mechanism, I'm going to do a for loop, I still want to verify that it's actually going to be declarative in its end state. So I'm going to run a Pulumi up here. And you'll notice that it's going to create 5 instances exactly. And because we changed the name of our original instance, it's going to remove that. But you'll see it's still declarative. It's still going to go ahead and create 5 of these instead of creating 1, even though we're using an imperative loop. The way that this works under the hood is that it's actually defining a schema. So you're using the Go programming language to author a declarative schema, but the end state is still going to be a declarative thing. Let's format that while that's running. So this is going ahead and it's going to create 5 EC2 instances. If we remember anything, it's going to take about a minute. While we're doing that, I'm going to look at the questions. How does the Pulumi API authenticate to AWS, GCP, Azure with the permissions required to create the infrastructure? It uses the standard AWS SDK. So you can see I have an AWS profile and you can see I've authenticated. So I just have AWS access keys. You can use AWS SSO. So if I use my Pulumi account, get caller identity, it's just going to use the standard mechanism. So you can pass access keys in environment variables. You can pass them to providers. You can do all kinds of different things. It's a fairly standard. If you can authenticate with the AWS Go SDK, which is what is being used under the hood, you can authenticate in the same manner with any other mechanism with Pulumi. Second silly question. Is there a reason for the name Pulumi? Yes, there's a blog post by our CEO, Joe Duffy. It's the Hawaiian word for broom. And one of Joe's closest friends was a guy called Chris Broom, who unfortunately passed away while they were building Pulumi, and they named it as an homage to him. What is the state stored as? Terraform has a JSON blob. Well, let me show you that right now. Pulumi stack output. Pulumi export, not output. This is what the state looks like. It is a JSON blob, and this is exactly what you would expect. It is not compatible with Terraform, but you will be able to store this into our Pulumi service. I would not be doing my job as a sales engineer if I didn't tell you that there were free tiers for the Pulumi service, and it's extremely cost effective. But if you do not want to use our Pulumi service, you can store this state inside a S3 bucket or a GCP bucket or an Azure blob storage. Can you import infrastructure state into it? Yes, you can. There is a really handy Pulumi import command, which will not only import things into the state, and I want to show you an example now because I think this is pretty cool. EC2, not only will it import things into the state, it will also generate the Pulumi code for you in order to actually pass it into the state. I don't have an example to hand right now, but if you run Pulumi import against a existing piece of infrastructure, Pulumi will output the code for you that you need to copy into your Pulumi program. So you don't need to do Pulumi import and author a bunch of Terraform manually. You just do Pulumi import, it imports it into the state, and then it will also import it, generate the actual code for you. Can you selectively remove infrastructure state? Yes, you can. You can use the Pulumi state command. And so we have a delete property here. So let's do Pulumi stack show URNs. So these are all the different things, pieces of infrastructure inside our stack. And then I can do Pulumi state delete like so. Yes. So now that particular web server is no longer owned. And if I do Pulumi up, it will probably tell me then it needs to create one piece of EC2 infrastructure. So it's got to create that. So you can remove things from state in much the same as where you can as with Terraform. I am a former heavy Terraform user. What I will say is that I have to do way less state manipulation with Pulumi because Pulumi has a mechanism called aliases. So if you're refactoring anything within your Pulumi code, within your Go programming language, you can just alias it to the old URN, and you no longer have to do anything like Pulumi state move. So we don't even have a move command, although you can disown things from the actual state. Any other questions? I assume these requests go via a Pulumi server to manage the service to get correct. Nope, that is not correct. Pulumi operates entirely within the context of your local machine. So what I'll do is I'll do Pulumi logout, and then I'll do Pulumi login -- local. And so now I'm logging all of my state to a local file. I can still run Pulumi up. I need to set a passphrase to encrypt everything because Pulumi will encrypt everything by default. And it will go ahead and create a whole new bunch of instances because the actual state that I was previously using is no longer there. Pulumi operates entirely locally. The only thing that we store in the Pulumi state is this state, within the Pulumi service, is this state here. So we actually calculate the number of credits based on the number of resources that you have stored in the state. It's not dependent on the web server at all. Any other questions? I do have a really cool demo to do next, so we might run over just a little bit, but it gets even better from here. I'm really enjoying all these questions, but this is a really simple demo. So I'm going to show you an even more fun demo in just a second. Hopefully I got to everybody's questions. If I didn't, then I'm happy to take any more at the end. I don't have a hard stop at the top of the hour, so if there's any other questions, but I do want to make sure we get through all the demo. Okay. So just as a reminder, we support all these different programming languages, and we also support VB.NET. I would highly encourage taking a look at my blog post about how awesome it is authoring infrastructure with VB.NET. Look how beautiful this looks. This is just the purest form of programming language if you want to use VB.NET as a mechanism. I personally like it because I started out in the industry with VB.NET, but not everybody has the same opinions. So we support all these different programming languages, but there's more. There's more to just authoring Pulumi programs and running them with Pulumi up. So one of the things that we announced this year is what we call multi-language abstractions, multi-language packages. So you can build infrastructure packages in the Go programming language, and then you can consume them in Pulumi's other supported languages. I'm going to show you what I mean by that in a few seconds. But what that means is we previously had a problem in which you wrote an abstraction, like a reusable abstraction in the Pulumi language, and then you had to rewrite it in all of the other supported Pulumi languages like TypeScript and Python and .NET. And that was a huge maintenance burden. It meant that you were essentially writing things 4 times. That is no longer the case. So if you build something, if you build an abstraction like a best practice VPC for AWS or something in Azure or something like that, you can publish those packages to all of the different supported providers and reach all of those ecosystems. And I'll show you what that means, what it looks like in a second. And also, you can build custom workflows within Pulumi. So what you've already seen is me driving my infrastructure configuration using the Pulumi up CLI. However, if you're building an infrastructure platform, you might want to define your own custom CLI. You might want to build a web interface that you actually drive Pulumi with. And a lot of this doesn't make much sense until I show you what I mean. So I'm just going to log back in again. Pulumi login. And I'm going to authenticate. So this is just an example of me authenticating to the CLI. And you can see I've logged into our Pulumi CLI. Okay, so what as a bit of preparation, I defined a Kubernetes cluster with Pulumi. And I'm going to open up this CD provider code. Let's make that full screen. So what I've done here is I've defined in Go a best practice production application to deploy to Kubernetes. I've used Kubernetes because I'm pretty familiar with it, but you can do this with any of the SDKs that Pulumi supports. And this has created what we call a multi-language component. So you can see here, it's all authored in the Go programming language. So I'm creating a Kubernetes deployment, I'm creating a Kubernetes service, I'm creating a Kubernetes namespace, et cetera, very similar to the experience that I had a few moments ago. And there's 2 mechanisms that I can use to actually deploy using this production application. I can either use inside this examples folder, I can either use my Node.js example, ls Node.js, index.ts. So you can see here, I'm able to actually consume this Go module as an NPM package. So I can do my production application, which my struct here, that's the wrong VS Code. You'll notice that my struct here, my production app arguments, has image and port as its inputs. And you'll also notice that I have that in my TypeScript SDK. I can specify the image and the port. This cross-language capability means if you're defining infrastructure, you no longer only reach one language ecosystem. It's super, super powerful. And I'm just going to run a quick Pulumi up here, and there's no Pulumi project in there. So I need to go into Node.js. There we go. That's better. Pulumi up. And under the hood, this is actually running a Go binary behind the scenes. So you can see it's going to create a production deployment. It's going to create a namespace. It's going to create a service and a deployment, et cetera, et cetera. This is one mechanism. And I can also do this in my Python example as well. The exact same code is going to consume this Go binary, dev stack. So these cross-language capabilities are really accentuated by the Go programming language, because it means I can create binaries that are just kind of self-contained binaries that live on my machine and instantiate this infrastructure, and then I can just consume it with our actual Python or .NET SDKs. So that's an example of the cross-language capabilities, but I also promised you your own custom workflows. So what I'm going to do is show you an example of CLI. So if I go into CLI, let me make this a bit bigger. What I've also done here is I've used Pulumi, a Pulumi mechanism called the automation API, to define a custom command line interface to do my Pulumi deployment. So instead of running Pulumi up as the driver, I've created a custom command line tool that allows you to abstract away all of the different things. And so you can see here, I've used the Kingpin library, and I've said that I only want to specify an image and a port. And then I've used a really fun, awesome library called Lipgloss that allows you to define really nice user interfaces. And so what I'm going to do is I'm going to deploy my production application. Instead of using Pulumi up, I am going to use my little prod app binary here. Prod app, come on, Lee. Bin, prod app, help. And I need to specify a name for my deployment. I'm going to call it Bristol. And then I just need to specify an image equals Nginx latest, like so. Unknown long flag. Oh, that's what I did wrong. There we go. What did I do wrong here? There we go. That's more like it. Name equals Bristol. And this is running Pulumi behind the scenes. So this is a custom workflow that is still going to deploy to a Kubernetes cluster. So you can see it's creating my namespace. It's going to create my deployment in a second. This is still running Pulumi behind the scenes, but it's all built into my own custom workflow. You can build Heroku-like experiences with your own command line tools without having to do any Pulumi up. So if you think about what that would mean in terms of how it looks in a CI/CD pipeline or something along those lines, you can build your own production application, et cetera, et cetera. And of course, just to round it out, I also wrote a source. This is in Python. So I wrote a little Python application that also does a similar thing. Localhost 5000. And if I really wanted to, I could do deployments from a web application. Again, it's going to use Pulumi behind the scenes here. Test, Nginx latest, port 80. Let's make sure I get it right. Again, this is still using my Golang binary behind the scenes, right? Like it's still using my Golang, my Go authored component behind the scenes, but you can see it's creating my infrastructure directly from a web interface. If you're working in a platform team, if you're working in an environment where you want to create best practice implementations and you don't want to have to define, you don't want to have people write a bunch of Go code, Pulumi gives you all of those capabilities. And I should be able to look at my test deployment and things should be good. So I've absolutely motored through that because I was running out of time. So there's a bunch of resources. I'll put the links to the link to the slide in the chat before I get out of here and before I let you all go back to your evenings. It was a really fast set of demos there. I'm really trying to just show you the possibilities and what you're capable of doing with Pulumi. But I'm going to finish with a quick sales pitch. The current crop of infrastructure tools or infrastructure as code tools are designed for operators. They're designed for system administrators. They're designed for DevOps engineers, whatever the hell that means. We at Pulumi believe that everybody should be able to provision things into the cloud, whether it's a front-end TypeScript engineer, a data science user using Python, somebody using .NET, or yourselves as Go programmers. You should be able to use the tools that you're already using on a day-to-day basis when you're defining applications. You should be able to use those same tools to define your infrastructure. And with that, I will say thank you. I'm going to look at the chat real quick to look at some of the different questions, but I appreciate everybody listening to me for just about an hour now. I know it's getting late into your evening over there in the UK. I really appreciate the time. Please do follow us on Twitter, but I really, really enjoy the opportunity to talk to you, and I'm going to take a look at some of the questions. We already covered the state storage. I assume these requests go to via Pulumi server. We already answered that. Glad to see that you're going to have a play tomorrow, Craig. I appreciate it. Do you have predefined modules for infrastructure like a GKA module project? And I'm using Terraform GCP analogies. The answer to that question right now is no. And here's the reason why. It comes back to the problem that I talked about with these abstractions, right? We try to build a module of reusable components. We have a library called AWS X or Crosswalk, and we defined it in one language. And then we realized the maintenance burden of maintaining all of these different modules in 4 different language ecosystems. And we're probably going to add more languages next year. So there's that consideration as well. We just realized the maintenance burden was too high. So we stopped working on abstractions and started working on multi-language capabilities. Now that we have multi-language capabilities, we intend to kind of double back and start to build reusable abstractions. In Terraform, you call them modules. In Pulumi, we call them component resources. We intend to build component resources this year. We already have a few. So if I do pulumi.com, let me just go to my web browser again. Out of full screen. Pulumi.com/registry. So we're starting to build these out already. And if you go to type component, these are all the different ones. We have an EKS component. We have an API gateway component, blah, blah. We intend to build many, many more of these. And we're also working on this module registry that will allow you to submit your own as well. And part of the thing that I'm hoping to get out of this talk is that once you start to, take a look at the, once you start to take a look at the capabilities of Pulumi, you'll start to build components as well. We're obviously a long way behind Terraform's module registry because they've obviously had 5 years head start on us. But we do think that this is the correct way to do things in terms of multi-language capabilities. So does it make sense to do this because we are using programming language? Hopefully that question has been answered. And then finally, wow, so you can wrap a very specific API and workflow into a single binary CLI. You absolutely can do that. Yes. I created another example of this. It's called run my damn GitHub. Run my damn container. So this is another example of a reusable binary or a reusable thing like this. And you can see I can create using all of the different cloud providers, different mechanisms. I can create using Cloud Run. I can create using Azure, whatever the Azure thing is, and then Google Cloud Run, AWS containers, et cetera, You can create those reusable binaries and just propagate them. So, if you're used to defining infrastructure and having people run Terraform in it, et cetera, that is no longer the case. You can just build a Go binary, put it in a homebrew repository, and just let them define things themselves. Okay, I've talked a lot. I know that I've covered a lot of ground. For all you folks here. Hopefully that was hopefully that got everybody. I can see some people saying they're excited, which is all I really want from this. If you are interested in chatting with me, I am always in the Pulumi Slack. So I think I just shared my screen again. If you go to slack.pulumi.com, we have a community Slack. Just hit this button, join and sign in. Join the community, and I'm always in there helping people out. I'm also on Twitter at Briggs. If you want to DM me directly, if there's any questions that you have, I'm happy to help people get started. I know this is a really strong community, and I'm really looking forward to seeing what people will build.